one and all. I am Manish Mesuria, Assistant Professor in Mechanical Engineering Department, Parul University. We are gathered here for the learning and understanding the promising topic on the emission discounting for the industrial and corporate social responsibility. Now, I would like to introduce our resource person, Dr. Amit Patel, sir. Sir had completed his PhD from the IIT Ropar. Sir had been awarded Extramural Young Scientist by the CSIR India in 2004. He had 20 plus year academic experience and 8 year the industrial experience as a energy auditor. Sir published more than 30 plus research articles and 4 unique patents. Sir has a 12 research get score. Amit Patel sir is now working as an associate professor in mechanical engineering department at the Maharaja Sayaji Rao University of Baroda. Sir, now I'm request to hand over the session to you, sir.
Okay, thank you. Thank you for organizing this webinar and inviting me. So I will start with sharing my screen. So is this screen is on your
Yes, sir. Yes, sir.
vision?
Yes, sir.
Am I getting this screen you now?
Yes, sir.
Okay. So fine. Let us start. Our topic, today's topic is yes. Today's topic is emission discounting number for industry and CSR. We heard this corporate social responsibility word several times. Now, what is corporate social responsibilities? These days, we are listening a lot about industry doing for society, right? Offering schools, making hospitals, making traffic arrangements and gardens, sport facility, sponsoring many events, right? Marathons and things like that. Now the question is, what is the motive behind doing all this activity? Is that corporate actually wants to do something for the society, right? Now let you tell you that these days, earlier when we were defining an industry, we were thinking industry from only one angle, is that industry should make profit, right? So only financial gain was a real aspect of any industry. But these days we have experienced and witnessed lot of industry polluting the environment, harassing the society, creating the disturbances and things like that. So these days, the corporate definition or industry definition is really wide one, that it should not only generate the revenue, but it should also be having positive effect on the environment. At the same time, it should be having improvement on the life of the people associated with it, right? So these three things taken together should make a real corporate shining. So with taking this in the mind, corporate wants to spread its wing in the area of social responsibility, in the area of environmental, degradation, avoiding things, and all such issues. So in this, corporate is working in a several different facet of the society. Here, the issue is when we have a lot of company working all and doing all these activity, do we have any parameter or is a benchmark to evaluate how they are working, whether they are working in the right direction, what are their effectiveness, what are those returns, are the returns in the social upliftment are measurable, and there are so many other things. Now to account this and to understand this effectively, we need some link or we need some mechanism which account or compute this thing in a hardcore numbers. So do we have any numbers for this? for that. But unfortunately, if you see, just for example, you take a power plant. What power plant is doing is generating lot of CO2 and releasing CO2 in the environment. In this scenario, these CO2 that it releases, are we really taking the correct amount of effect of CO2 on the environment? Are we computing that if on one hand they are making profit and on another hand they are polluting the environment, is its real cost accounted? Then probably we don't have any model, we don't have any answers, we do not have any definite mechanism to compute it, right? So in total we say that there are a lot of companies are working haphazardly in the direction of CSR, but a measurable yardstick or parameters are missing. So in this pocket, right, in this pocket, now today's discussion is actually amplifying this effect and give you a measurable yardstick to account your emission going into the environment, right? You must have heard about the life cycle analysis. Now life cycle analysis is giving you the cost of emission during the life of the machine or the life of the product, right? But life of emission is different. Life of emission is far beyond what the life of machine is there. Maybe machine working only for 15 years and it will be dumped, right? It will be destroyed, it will be salvaged, and the things are over. But emission is not a matter of only 15 years. It lasts even beyond many years besides what the machine is over, right? So our measurement of emission should be the criteria and not the industry's life is the criteria. So in all these arguments, our today's model is based on. So let us understand what is emission first. So emission in any many literature is considered as a disturbance, right? Disturbance, especially in environment arena, they call it as a disturbance. And when you say emission as having a multiple effect, so it can be very similarly explained in if you have a single emission, then its effect is like a drop of water on a stagnant water, and its effect can be visualized by spread of pressure waves on top of your water level. But when you take multiple disturbances, say for example, there are so many industries running simultaneously, generating CO2 emissions. Some are polluting water, some are polluting ground levels, and many way they are polluting simultaneously. Then that emission can be considered as the disturbance created by a swarm of a bird, right, on top of the water level. So how to compute this emission? So we just tried and pictorialize you what is the disturbance. Now CO2 generation is similar disturbance. There we have a similar effect, and their accounting is so complicated. So let us start with what are the mitigation waves that we have, right? How we can, what are the options to absorb the CO2? See, we have so many options to generate the CO2, but very few options where we can actually, mitigate CO2, reduce the CO2, reverse the effect of CO2 and things like that. Here on your screen, if you find, we have listed so many technology that generates, say, for electricity. These all technologies are basically generating electricity, and if you see on a last column, you will find out that emission generation per unit of electricity is varying, significantly varying. Minimum for the wind, which is very negligible, say 9 gram of CO2 per unit of electricity, and very high, say for example in case of coal, we have huge number around 1,000, right? So these numbers are basically, this spectrum basically gives you a vision to look the energy generation system with an angle of emission, right? We hardly why we see these days solar photovoltaic we are employing, but why we are employing solar photovoltaic? Basically because some subsidy or some our financial gain, our electricity bill is paining us, and all sorts of reason. But do we really see this electricity generation with emission point of view? No, it's we don't ever see it, and we think that it's a baby of a government to see all this, and we never consider these things to be our priority, right? But these aspects are many times missing, right? So our objective here is to see why we are taking electricity generation is because most of the emission, right, around say 70%, 80% of emission is being generated in the process of generating electricity, right? So that's why we are focusing a large chunk of emission dedicated to electricity itself, and that's why this spectrum is discussed here. Here, one very small but very basic example is given where what we are doing is we are using diesel and generating electricity. This is very common seen in off-grid scenarios in many rural areas, some farmland, or many places. You will find this kind of system. Now, these are the basic system where we are actually releasing indefinite number of carbon emission in the environment, and we are generating electricity. So this is one side. These all are one side. But if you have options to mitigate it, then what really options you have? Then you can say yes, we have an option where we can store the carbon in say growing biomass, right? Now, see, these days, earlier people used to neglect the wood and biomass with the basic reason that biomass is basically thought to be very primitive kind of fuel, and people were very obsessed with see fossil fuel, diesels and things, very compact, cheaply available. But scenario changed recently because shortages, because environmental concern, because of monopolized sources by OPEC countries, and so many other reasons, right? So because of all these, people started looking for an option, and they found out some options. But what they really find is the biomass is the only option where you can really arrest carbon and lock it for a long period, right? See, carbon you can absorb in several ways. You have a carbon sequestration. I mean, CO2 can be even in many cases dumped in the sea water also. CO2, you have a lot of empty well of CO2. They're dumping CO2, locking it at a high pressure, and keeping it like that for years and years. But during all this, very natural, very common, most cheap, and most environmental friendly option is biomass. So these days, biomass is started getting attention from several different angles, right? So this is one of the benefit of using biomass. So biomass is actually one of the means to lock your carbon headache. Right? So so here it is the same thing, that carbon sequestration by afforestation. So a large artificial forest can be created, and we can lock this carbon into this thing, and large amount of carbon is being locked. See, and here you don't need to pay anything. Suppose, I mean, you are locking carbon CO2 in say sea water. Then the issue is sea water become acidic. Issue is that your plant animal lives should be affected. So many other things. But here in this case, you need not to bother anything. So it's the cheapest carbon sequestration option. Another option we have is, what we do is a country has lot of agro waste, and why we are talking about agro waste is because an agrarian country like India has several surplus agriculture waste. Now, what we are doing with this agriculture waste, we are not having any systematic channel for that. Either it is used for fodder for the animal, or it is being burned and created emissions and things like that. If we can channelize it in making pellets, which you see on top left corner, right? If you make this pellet and you have some processes where you can generate the pellets converted into a coal like structure, which is known as biochar. And if you crush it and mix with the land, right, then your productivity actually enhances of the crop. So this is a benefit. And another additional benefit is your carbon is being sent back to the system of your this thing farming, and your cycle is complete. So farming cycle is complete. Here we are describing all these a typical process with the help of one system. What system is that? We have a field where you are generating excess agro residue, which is unused, right? So what we can do is you can collect it, bring it to some small places. You have one machine called pelletizer, which is shown here. This machine will produce pellets like this. Then comes a unit called pyroformer, and this pyroformer is the unit where these pellets will be heated, right? Heated in absence of oxygen. So what happens? Vapor will be generated, and as you can see on your clip here, pyroformer is having a condenser where this vapor will be condensed, and whatever you generate, right, will be known as bio oil, which is shown in your next slide here, correct? So here bio oil is being converted, collected. Then what to do with this bio oil? Bio oil can be used in the engine, is one of the application, and some of the gases which cannot be condensed can be burned. But very important issue is here, what you do with the remaining of your pellets. The remaining of pellets here is shown with a container where biochar is written here. So this biochar basically is a very high porous structure. Why porous structure? Because when you heat it in absence of oxygen, it will not be able to burn, right? Instead, it will create a several pockets where your vapor will be allowed to escape from the wooden structure or biomass structure, and you have a highly porous, material. These porous material will be called as biochar. And in these material, if you have a particular process in which you do it, your all metallic component, which are very important for your farming activity, we loosely say minerals, right? So these minerals will be preserved in the structure itself. So when you mix this material with the land, right, farming land, so what will happen? Your microbial colony will be having encouraged to stay in this porous structure. They will have a ready-made house to stay. And they grow in colony and they generate nitrogen, right? These nitrogen will be a favorite food for the crop's root, and your crop's productivity will increase. So actually this agro waste is converted into a small kind of a fertilizer. So this will increase your crop. So why we are discussing all these is here in this process unknowingly, we are trying to increase the crop, but at the same time additional benefit we are getting is what we are locking this carbon into the land for the years to come. So the question is this carbon locked permanently in the land? Yes, we will answer this soon, but these slides gives you a statistics where what we have done is we have created two fields, right, of say 80 square meter, right, each, and we planted in this thing two particular kind of a crop. One crop was capsicum and one crop was onion. In both, we will find that due to the addition of biochar compared to non-addition of biochar, the increase in productivity of crop is observed in both the cases. So this is an evidence that your biochar is really or actually acting as a fertilizer. And once you prove it, right, for a given agro residue, you can later on go on a mass scale and keep on adding it with your land, right? So this is what one of the benefit of creating carbon and locking this carbon in the land. The question we were addressing is, does this carbon lock forever, years and years? Then the answer is, if you mix say 1 kg of carbon in the land, then I will say 20% of this carbon component will be converted into CO2 and it will be escaped back in the environment. So 20% of carbon sequestration will be non-permanent, but that 80% component is a permanent component, and that component may last for years and years to come. And some of the evidence that we obtained during excavation in areas like Brazil, we found that the carbon actually locked in the land 5,000 years back, even identified today, right? So they are even prevailing even these days. So this is a really a permanent kind of activity, and it actually enhances the eco-friendly nature and not giving any disturbances. So these are what we are discussing is one aspect or one way in which we can get this activity of locking the carbon. Another similar activity of locking the carbon is using agro residue, say crop waste, reminder of crop, etc. in anaerobic digestion, where we can generate the biogas. We can even further link this with the public toilets and things like that. So why we are talking all this is because these are CSR activity, and what happens is that if you use it for generating biogas, what you get is a gas to use for cooking and electricity purpose, and at the same time you are avoiding large release of methane. Right? Where from this methane will come? Whenever biomass will be decayed in open air, it will generate large amount of methane, and these methane is having very huge environmental effect, even higher effect compared to CO2. So methane is 21 times more environmentally influencing than CO2. So this is a very huge beneficial, right? So the if you do this activity, what is financial benefit? So this will struck to our mind that yes, all these activity are for social work. Do we have any financial gain? Then yes, we can say that you can earn, or any company doing this can definitely earn a carbon credit. What is carbon credit? Is that if you prove that you are avoiding some generation of CO2, right, by your activity, then that kg of CO2 equivalent money, right, will be your credit, and these credit you can sell also. That means the mechanism is something like that. So X company is generating CO2 and Y company is absorbing CO2. Then the mechanism is that Y company will be given some carbon credit. These credit Y company can sell to X. So X can say that by purchasing this credit from company Y, now it is environmental friendly. Are you clear? So this is how carbon credit mechanism works. So a person who is doing only carbon sequestration or only carbon absorption can also earn, or it can earn its credit to the company who is producing the carbon. So this is one of the financial aspect of these activities. Now, another aspect of the mathematical model that we propose to discuss, that earlier we stated an idea that there should be some number, and that number should speak on its own the effect of emission or effect of a process on the environment. And if this effect is computed in terms of number, then we can certainly compare number of process and say that which process is best. We can say that yes, Y process is best and it has this percentage liability on the environment. So our final objective is to compute this emission activity, right? Now the what is present mechanism in computing? As such, we do not have any computing model now, and we have a life cycle emission concept. In this life cycle emission concept, we do not have time component into account. What is the time component? Is that suppose you a company is having 15 years of life of a machine, right? And we say that every year it is generating some emission. That emission, suppose it is emitting in first year or 15 years, they both are mathematically same for the people. However, for environment it is not safe. Why? Because during 1 to 15th year, if that amount of CO2 is not in the environment, then the environment global warming effect would be reduced definitely, and company should be benefited because he delayed the release of carbon emission. So this time value of emission was not in computation or accounting, and that we will really going to discuss it. But here we are introducing one another idea. Is that suppose I am having here it is shown. So for example, a factory is shown, right? And there is some emission released from the factory. And what we are accounting is the process emission. And process emission will take place only when the company is working. Say for example, company is working in 8 hours a day. Then its process is 8 hours. Then emission will be accounted only for 8 hours. But if you really observe that whatever the building material is erected, whatever the plant site is made, there also you a company has consumed lot of material. For example, they have consumed lot of steel in creating and building this infrastructure. And when you create a structure steel ready for such construction activity, you will realize lot of CO2 is being generated during the production of steel also. So that if you want to account everything into your carbon emission activity, then you should not forget the process emission as well as emission by the system. Now, what is system? That suppose there is some facility building, for example, you have a plant, you have machines, right? So machine also have a lot of material, and that lot of material might already had consumed lot of or emitted lot of CO2. So if you account that into your calculation, I will say that your calculation not only computing the variable component of emission during the process, but a fixed component emission that has occurred even before your process started. So that kind of emission is referred in the literature as embedded emission, right? At present, I mean, before this work, I'm telling you, there were not clear having any guideline of emission during the process or emission during the creating building a machine, different machining activity, etc., etc. So during this process, we came out with one method of accounting those emission, right? What method? And additionally, this is very relevant. See, this is the same chart that we have seen earlier, right? That emission here is represented for several power generating system. Now here, when you say a emission in case of wind is only 9 kg of CO2 per unit of electricity, what does it mean? This means only variable component. You have not accounted a large structure required for wind, right? You have not accounted large, PP material that goes into, say, for example, creating blades of the wind. All that is not accounted. If you are generating large CO2 in creating wind, blade of the wind, etc., etc., then our entire purpose of renewable system is not vitiated as such, right? So, is such any cases really occurring? Yes, then I will say these such cases are really there. Say, for example, you take solar photovoltaic. In solar photovoltaic, we are very happy that we are getting green electricity. Yes, it is green electricity. But have you ever thought that the battery which is used in solar photovoltaic for storing electricity is having using high amount of lead, right? And this lead having large environmental impact, a very huge environmental effect, and it is detrimental. What we have done is we have given exemption to the use of lead for sort of solar photovoltaic battery, and that is why I say that solar photovoltaic is environment friendly. However, actually, when you see embedded emission for generating batteries, this is not a represented correct figure, right? So what should we do? Our same process is again. This time we will discuss something else. Our process is understood, right? Is if you are creating, say, biochar, right? If you are creating a biochar, then biochar is not a free quantity. Why it is not free quantity? Because in producing the biochar is also having its footprint. What is footprint means? You already created lot of CO2 in creating this biochar. What amount of CO2 we are talking is that two types of CO2 emission. One is creating the facility, like creating pyroformer, erecting machines like pelletizer, and then engines. All units might have pre CO2 generation into the system. So this CO2, which is generated even before the starting of process, are to be considered as an embedded emission. So what we can say that, and if just I say that biochar is environment friendly and this is the carbon sequestration is not done, I must account right from the field where you are creating the agro residue, how you are transporting this agro residue. If you are transporting by truck, then you might have used diesel, and in that case diesel must have done some CO2 emission. Are we accounting that CO2 emission? If no, then biochar is not a correct representation of carbon sequestration, right? We are hiding those figures, so that's not correct. So what we should do is we should consider all and every component where CO2 is either generated in any fashion possible. So here what we should do is, this actually table shows you that emission, right? Embodied emission, or say embedded emission, right? In terms of different processes. Material, when I say, means excavation and processing of material. See, we get structured steel available ready. What we do is we go and purchase steel from the showrooms and go downs, and then we use it in creating building and structures. But that material already has process emission. So do we have that numbers? Yes, some of the literature suggests some number. That number, it's a range they have suggested, that if you use cast iron as your material, the first column and first material is cast iron, where your emission is in terms of megajoule per kg, right? It says that it will vary from 16 to 18, range of 16 to 18. Right? Similarly, if you use mild steel, it has some range. If you use, structure steel or stainless steel in different combinations, it has range. Then you have aluminum alloy, it has some emission range. So these are the range collected from several literature and made it bundled into a table. Then next is different processes. Say, for example, casting process. The casting process itself will have some process emission for different material. Then you have a deformation process. Deformation process means it can be either bending, it can be either cutting, it can be either welding. So many different process, deformation process. So all emissions for such processes are here listed here. And then what you do is, at the same say, suppose you are using a machine, right? these machines, suppose life of the machine is 15 years. So what you they say that in first year you should account all the CO2 it has released at the time of purchase of machine, right? And installing it in the lab. So once that CO2 is there, but in this CO2 we must give the credit of some CO2, because after 15 years this machine will be life is over and it will be salvaged. Some portion of this machine will be recycled. So when you recycle some part, at that time already you have computed CO emission once, so second emissions you should not take. So that time, the when you recycle your machine, the credit should be given to earlier emission. So recycle component is a negative component and will be deducted from all actual emission generated during the process of making a machine or a plant or facility, whatever, right? So this is the energy, upper is the energy and bottom is the emission. So you will also consume energy at the same time also emission. So these are the data which is compiled from several literature. Then what we are doing is we are listing various part for my pyrolysis process, for the process that I have shown here. This process, I will list what are the different machines used in this process. Then I will say these many machines I am using. One is chopping machine to make small parts of my agro residue. Then I have a pelletizer machine which is creating pellets. Then I have a pyrolyzer machine which actually creates the biochar, right? And then I also have an engine where my fuel is being burned. So for all these machine, what I will do, I will list down what are the material I am using, right? So list down this material, and based on this material I will list down what are the processes also. So doing all this, finally I will get some list where different machine will have a different emissions, and I will get some net emission, right? Here I will have some point just to get. I will have some net emission here. This is net emission. So I will net emission. I will list emission and energy both. But emission is of my use here in this case. So I will write down 86 is the emission, embedded emission of the chopper. Then I will say pelletizer is also having some CO2 emitted while it is machine was making ready. So this component is obtained 128, and similar engines and pyrolyzer. After creating this, what I will do, I will use it in my analysis. I am also discussing about some different numbers. What are these numbers? There is something called grid emission. So when I say I'm sitting in a room and I'm running a fan, I cannot say I have not done any CO2 generation. Why? Because when I use electricity in India is coming from several different sources. One is fossil fuel, one is nuclear, one is renewable. Only 16% is coming from renewable, right? Only 16% is coming from renewable. It's a very small component. What rest is having a lot of emission. So I say that my electricity which is coming out, say 1 unit of electricity, 81% was fossil electricity generation from fossil fuel. Nuclear, although I say that very less emission, but there should be some emission for that also. So if I account the overall emission of my 1 unit of electricity, I will say it's not zero, right? It's not 100. Had it been 100% renewable, maybe zero, but not. So I will say government releases some data that kg of CO2 generated per generation of unit of electricity is 0.84. That means if I'm using 1 unit of electricity in sitting room and running fan, right, in running fan, then I can say that this actually consumes the electricity and emission is released, right? 0.84 emission release, even if I am taking emission from grid. This we say that indirect electricity emission. Why indirect? Because it is not emission release now, but I am using some quantity which has its emission footprint on it. So those emissions should be accounted. Then transportation emission, there are some numbers for that. So if you use say 0.97 kg of CO2 per ton of kilometer of transportation of goods, and where you will need to account this here in this case is because your agro residue is a very light material. It will occupy large space, and emission will be very large behind that. Then again, if you burn fuel, the fuel footprint is very simple to calculate because composition of diesel is known to us. So 3.19 kg of CO2 is statistics for the use of diesel. All these discussions were some numbers, right? Some concepts. Now coming to model, that in order to calculate the emission number, what model is going behind it. Then I say that to understand this, I will first divide my processes into different classification. What our classification is? First is, I will say, embedded emission. We have just now discussed what is embedded emissions and things like that. That emission already occurred in creating the plant. So that is embedded emission. Then second is a emission because of transportation. That we have also seen. Suppose your material is moved from one place to another by say truck. Then use of diesel, and that emission is a type B of emission, right? There is also something called type C emission. Type C emission is emission that is released during the process. What emission during the process? Means suppose I burn diesel and obtain electricity, right? So that process is having some CO2 released. Say I'm creating say some process. I'm burning wood and I'm generating steam. Then I will say yes, I generate some CO2 emission. So such emissions are type C. So emission should be accounted in that cases. Then I have some emission called biomass emission. Here I have intentionally given one example of use of wood. What I mean to say, when I use wood when I burn, I will release some CO2, but this CO2 is already absorbed by the wood. So I say that burning of wood is environmentally neutral. So such type of emission is type D, right? Either I burn straw, either I burn wood, any biomass I burn which has a structured carbon into absorption, right? In that structure earlier, then emission of that is environment friendly. So that is type D emission. And finally, type E emission is emission by sequestration. So whatever CO2, equivalent CO2, I sequester, or say I lock the carbon for a very long period. Suppose my process is say growing tree, right? Not always I'm dealing with machine. My process is growing tree. Then I have the amount of carbon locked in my this thing is basically, I will say, as a mass of wood that I am generating, correct? So this mass is type E because I am locking my CO2 for many years, and if I use this for burying in earth, then it is locked permanently. So mathematically, if I see, the formula goes something like this: that type A, B, and C are releasing environment, CO2 in the environment, whereas type D and type E are absorbing emission or neutral to the environment, right? So if I put it balance both, I put it on left side the emission release, and on right side suppose I say emission absorbed, and if somehow I balance both the sides, right, then can I say that my effect of emission in the environment is neutral, because whatever the process has released the CO2, that's the same process has absorbed by environment. So this is what basic model is, right? And then comes, this is the same thing we discussed, I'm skipping it. So then comes the different type of modeling. First modeling type is that when I have say 1 kg of CO2, that effect of 1 kg of CO2 is reduced over 100 year. So it is assumed that whatever the emission you generate, the life of that emission is 100 year. That means in first year, suppose you have released 1 kg of CO2, what will be the amount mass of CO2 in second year? Second year is less than that. Third year will be even less than that. Why? Because it has to finished by end of 100 year. So it will have a exponential decay curve, right? And that mathematics is shown in the formula here, that if d1 is a unit damage of 1 kg of CO2, then its deterioration chart can be given as dn, that means damage in different years, represented by this mathematical formula. Clear? Next is, while deciding the decay, right? What rate I am considering? Suppose I am considering, there are various options. I can say decay by reduction by 1%, then I rate is -1. If my decay is by 2%, then reduction is -2, and things like that. So this is a question of choosing a appropriate decay curve. But finally, and by 100 year, it has to terminate, and first year it has effect is 100%. So I can choose different path depending on my different rate I am considering. Next is, say if I what I do is, if my different year of operation I assume, say there is one factory, and life of the all machine of the factory is coincidentally same, and that is 15 years, right? So if that life is 15 years, then I will say that every year company will release some emission, and those emissions are every year different. Say for example, this is emission is of first year, right? Then you have same emission released by the company in the environment in second year. Then you also have the same emission released by company in third year, assuming that production of company in different years remains same. Let us assume a simple case where the production remains same for years and years. So this is emission for fourth year, and this is emission for fifth year. But when I apply my previous slides and previous method, I can say that these first year emission can be have a reducing effect on the environment, a dying effect like this, and it will complete its life, right? It will complete its life. Say for example, in this case I have considered life of emission is 15 years, then after 15 years it will be zero. Earlier case I have taken 100. Note this. Next company will have, I mean next year the same company will have some reducing similar series, and this series will have a emission zero by 16th year. Why 16th year? Because it has started emitting from second year, so it will last 16th year, and things like that. So what I can do is, if I add all the emissions year wise, say for example, what are emissions in my first year? Only this. So I say one component. My second year, how many component I have? This component, I have this component, then I have these component, and things like that. So if I make it year wise, then what I will get? I will get some distribution like this, right? This was just a sample, assuming that life is only 15 years. But however, life is never 15 years. And if I now consider realistic data, then I can say that life of a machine, if it is 15 years, damage life is 100 years, right? And if I get realistic data of the company, then my distribution will be something like this. So it will reduce, correct? So only in 15 years your graph will increase. Why? Because emission will be on 15 years. After 15 years, company's machine life is over, but the life of emission is still there, and it will deteriorate at its own rate, and that rate can be represented by formulas. Now comes balancing. As I told you that I have to balance emission generation as well as emission reduction. Now suppose my objective, say for example, initially we started discussing that company is doing CSR activity. Their objective is to see that they are not environmentally destructing and not liability to the society and things like that. Then company will certainly see that it should, all emissions should be balanced. That means release of emission and absorption absorption of emission, they both must be same or equal. Now the issue is, can it say that suppose I total emission I have generated in 15 years is say 500. So does that mean company will say I will absorb 500 kg of CO2 and I will be environment neutral? Then answer is simply no. Why? Because in first year that emission is lasted for 15 years. The second year emission is lasted for 14 years. So actually emission in the environment and its duration should both be accounted simultaneously. So to do this, what company should do? A company should do some realistic value addition with respect to time. Now here we have listed one concept. What concept is we have listed is that suppose one company is doing emission every year 1 kg of CO2, right? Which is shown with the red bar. Here it is shown with the red bar. If a company is say discounting this emission, right? Discounting this emission by say for example if it is discounting negatively, that means it is not doing any environmental absorption activity, then what's its effect will be? Its effect will be it will be more and more liability to the society because it is not doing any absorption activities. CO2 absorption is zero. If that is zero, then it I will say that it will be having larger and larger liability for the society. If company is doing even little say activity of absorbing CO2, then its discounting will be positive and its net effect will be reducing over the years. So this gives you idea what is positive discounting and what is negative discounting. So if I do some summation and I find that net positive companies is net effect is in red, then I will say company is liability to the environment. If I do some analysis and find that company is in green, then I will say this company is actually beneficial to the society. Right? So what I do is just to balance both, I I give a value of say this slope. This is the slope. Suppose I say this slope as one value x. At what slope these both are balancing x and y? Suppose these both slopes are given one value. At one particular point, they both are equal. And if that point is in the red color, I will say this is liability. If this point is in green color, I will say this is a beneficial to the environment. So that is called as a positive and negative discounting. There are some examples here given that what is positive discounting in real life. So you see, people are investing. Say our government is investing in creating a lot of IITs and a lot of research facilities and like that. Then they assume that these investment will pay us in a long time, right? So these investment is actually benefit in a long run. So this is considered as a positive discounting. And some of the example of negative discounting is scarce resources. Say for example, land. So you always see the price of land with negative discounting. Why? Because land price will definitely increase every year. Why it will increase? Because there is a shortage, right? Booking of railway ticket will always negative discounting. Why? It will always be more and more waiting list because more and more people will join the queue. So all such quantity which has a scarce resources, making resources scarce, are considered to be negative discounting, and the quantity which enhances your lifestyle, which gives you beneficial, gives you better return, are all considered as a positive discount. Right? So here what we are doing further is there is a case study is given, that case study of a simple milk unit. What is milk unit? Milk unit where we are collecting milk, processing it, packing it and sending it for a sale. That's it. So what are its different component? The different component is pasteurization first, then we store it milk for chilling purpose, then packing at some appropriate time and sending it for the transportation. So a company when it is doing all this activity, we will find it has a lot of CO2 locked in such machines. Say example, these machines were created, certain amount of CO2 definitely might have generated. So and then when we say that this is a unit, that also must have some CO2 locked inside in when it is being formed, when it is cut, when it is welded, when it is processed and things like that. So if I list down all these numbers, I will come to a figures like this. That pasteurization will have some statistic method we have discussed earlier. With that same method, I will come to a numbers. That numbers will be like this. And when I say I will use some say machine called biochar generation machine, then these numbers should also be accounted. Are you clear? So these numbers actually is embedded in once emitted numbers, right? So these numbers are there. Then company when it runs, it consumes certain electricity, and electricity is having some CO2 generation indirectly. So those are the component CO2 generation during the process. So these process emission and fixed component will make a case, right? So when what we do is these numbers are then compared, right? With some of the things we discussed that biochar, right? So in biochar, I say that 0.32% of kg of straw we are generating biochar, and 64% of the carbon will be there in that biochar, large number of carbon, and that is why we are after this biochar activity. Clear? So when you the calculation is very simple. First obtain the embedded emission, right? Then obtain the process emission. Both numbers are obtained. Then estimate the life of the machine. Then reducing series are to be obtained. Then add this series year wise. Then choose an appropriate slope for positive and negative. At whatever the slope you are having that slope as, say, in the red side, you say there is emission, and if you are on a green side, there is a liability. But you just see that this process is do not have any component which absorbs the carbon, right? You do not have any component which actually absorbs the carbon. सो व्हाट यू शुड डू, कोई एब्सॉर्प्शन हो ही नहीं रहा है, नहीं हो रहा है इसका मतलब तो डेफिनेटली ये रेड में होगा, तो नेट इफेक्ट विल बी पॉजिटिव. तो क्या करना चाहिए, इट्स इन ऑर्डर टू क्रिएट a impact of zero carbon emission, what company should do, company should absorb the carbon, right? Or it should purchase some biochar. So what amount of biochar company should purchase, that should be given by simple calculation, balancing CO2. तो अगर हमने बैलेंस कर दिया, then I will say, suppose I want to be environment neutral. Environment neutral means my impact is zero. I'm not on red, I'm not on green, I'm just balancing it. If I am balancing both, I'm almost at zero. Then I will say at that time I need to purchase 6 kg of biochar, right? 6 kg of biochar. And if the biochar cost is 4 rupees per kg, then my yearly worth of 65,000 every year. I say that my activity is environment neutral, and I can write in my CSR report that I am environmentally a neutral company. So this is what the calculation is, and this is what the benefit for a company. So this is what the conclusion. Conclusion is, in order to achieve carbon neutrality, such computations can be done, and company can state that it is a carbon neutral. Carbon neutral is a really good tag for a company, and it can attract lot of customer by just telling that it is having concern and it has gone through this exercise and it is a real carbon neutral company, and it has a good respect in the arena of its own loyalty of the customer. So This is exactly 1 hour, and I think we have completed the discussion. I will be happy if any one of you have questions.
Yes, sir. Yes, sir. It is a company. One questions arise from our faculty, sir.
Yeah,
The
yeah.
question is that why bio oil and biofuels are not as much appreciated by our government.
See, yes, this question is very relevant. Is that biodiesel is a very old product, but bio oil is a recent product, right? So when you create biodiesel, biodiesel is really appreciated, and at least 10% of mixing is already aimed. We are now going for 20%. Now coming to bio oil, the product of this process. Yes, biodiesel and bio oil is little bit different. Bio oil output says that you have some floating tar particle as well as char particle, and your engine suitability is not good in long run. So this is why these days people are more interested in carbon sequestration and not using fuel for engine. But yes, these fuel can be used for thermal applications, right? You want to generate the steam, then yes, you can use this fuel. At that time, there is no issue of tar, char, etc., etc. You can generate the thermal energy and you can definitely use it. So in this zone, yes, it has its effect, it has its impact, and you can definitely use it.
Okay, sir. Thank you, sir. Uh, Now, from the behalf of the Parul University and the Mechanical Automobile Department of PIT, I would like to thanks to Dr. Amit Patel, sir, for informating and fruitful webinar and for the sharing your grand knowledge with our students. And I hope that our students have learned so much from it. So, sir, thank you once again, as you have taken out of your busy schedule and agreed to give a wonderful presentation. Thank you, sir.
Okay, thank you, sir. Thank you, thank you.
Thank you, sir.